Welcome back to part 2 of our Prefect series. In this video, we are diving deep into the hands-on programming aspect of Prefect, building on what we've covered in the intro section. I'll be showcasing a live example using the repo that I have built, which is available in the description section of this video. And I'll be demonstrating how you can orchestrate complex workflows, including retry logic, asynchronous tasks, and large language model integrations in the end. So we'll explore at a very high level basic tasks and flows orchestration, setting up retry logic and handling failures, using parameterized deployments and workers, and then implementing the LLM use case with Prefect. So if you haven't checked out the introduction video, be sure to watch that one first. That will set some basics and the concepts of Prefect. And then now enough talking, let's just jump directly into the real world coding side of all the Prefect examples and use Prefect to its full potential. All right, so let's switch to the GitHub repo that I'll be using. And you can clone this repo as well. There is a requirements.txt file over here that we'll be installing very first, and then we will go on from there. But before I go over here, I just want to quick show you, there is this prefect.io. This is their web page. And this is the final server interface that we'll be having once we install Prefect server. And all that is very simple. Just one command will get you going. I have already installed Prefect, and I want to quick show you some of the features of Prefect, and then we will dive into the programming aspect of it. So the easiest way to install Prefect is just to set up a new Conda environment and install Prefect in it by using pip install. So if you see on the screen right now, I have a Conda create minus name. And the name that I've chosen is Prefect Test. You can choose any name that you like. And I've chosen Python as 3.11. And you'll see, because I already have a Python environment with this name, I'm just going to say no over here, but you can choose yes. And you will have a new Python environment created. And what you'll do over there is then Conda activate and Prefect Test, and it will activate your Conda environment. So you know that your Conda environment is activated by having Prefect Test. Do you need Conda for all this? No, you do not. But having Conda does help you in isolating your Python dependencies. So please do install it. You'll realize the benefit of Conda in future, but you do not necessarily need Conda for doing all this, whatever we are doing. All right, all that being said, the easiest way to get started with Prefect now is doing a pip install Prefect. Right, I've already done it, but that's why you saw that it kind of went through that fast, but it will take maybe like a minute or two for you, and you will get started with Prefect over there. And then you have to just do prefect server, a prefect start, I think. Let me double check. So prefect server start. Right, so we start the prefect server like that, and now you have your prefect server up and running on this particular URL, right? So let's copy this URL and let's take a look at the prefect server that is running in my local over here. So there you go. So it's asking me to join the community and all that. I'm gonna say no and skip. And this is your prefect server running in your local now. So you will see that there are certain flows and runs in my prefect server because I was playing around with it before making this video. So there are certain runs and certain flows, certain deployments, and we will go deeper into all of this. But I just wanted to quick show you that this is as simple as this. You can run your prefect server by just couple of commands in your terminal. So all we did is pip install prefect and prefect server start, and that is it. And it starts up your prefect server over here. All right, so now let's take a look at some other aspects. So what I'm gonna do now is shut down this prefect server that is up and running over here, and we will so let me shut it down. So it is gone. And what we'll do next is clone this GitHub repo that we have, right? So you'll just copy this over here, copy this, and go to any folder and just do a git clone of this repo, right? So let's do that. I have again already done a git clone of the repo, so I already have all the code over here, but all you need to do is just go to any folder of your choice, just do a git clone, and then just paste this thing over here and hit enter, and it will clone this repo in your local. I'm not going to do that again because I've already done it, but this is all that you need to do to get all this code in your local environment as well. Now, let's see what Prefect can do for us. So I'm going to get rid of this terminal, right? I'm going to let it go in the background and click on the terminal and new terminal so that I have this open. And please note, it says that Prefect test environment is already shown, activated over here, even though it is not shown. So even if it is not saying Prefect, it's okay because it has activated that environment. And the way you know that it has, you can type Prefect version and you can check certain aspects of Prefect. Knowing that the version is returning back as 304, you are having that Prefect environment activated. If you did not, it wouldn't have recognized this. All right, so we'll run the very first code without needing any Prefect at all. So right now we are, let me close everything else, close others. So we just have the very first file over here. If you see, it is the simplest of the simple hello world Python application that can exist. A say message method that is being called over here, right? So that's it. There's nothing fancy going on. It is just a say message method, and we are just calling it on the execution of this file. So let's run this particular file over here. So we'll just go into this folder and we will do Python, and the name of this file is 01 basic example with flows.py, and we will run this. And you will say it says hello. That's it. Nothing fancy about it. Now, if we go into our Prefect server, will this show up over there? No. No, it won't, because it is just a simple Python file. Even if you have your Prefect server running, which we do not, but even if you have your Prefect server running, it won't show up over there because there is no connection between your Python script right now and the Prefect server. So I won't start up the Prefect server yet, but I will add some code around it, and then you will see that the code will fail. And then why it is failing, I will talk about it too. So what we'll do is we'll import flow from Prefect, right? And of course, it is the other way around. My Java programming skills are kicking in over here. From Prefect, import flow. Right, so we get our flow imported, that decorator that we need, and I'll just add the @flow over here, which will decorate this particular method as a Prefect flow. Right, so we want to see this in our Prefect server. So if we run this method now, will this actually do anything? Will it actually run? Probably not. Why? Because this will make an attempt to register this flow in Prefect server, and it won't be able to because our Prefect server is not running. Let's try that. I'll run this program again, and if I hit enter, it will attempt to register this flow in Prefect server and fail to do that, and which is what we want to see over here. So it is making that attempt, most likely going to fail, and there we go. So it tried to reach out to the API which is hosted for Prefect server. It couldn't find it, and it failed to do that. So how do we fix this? So all we have to do is to just turn on our Prefect server. So we'll just do Prefect server start, and then we will run the same program again. Right, so we started our Prefect server, and we'll run the same program again. And now it will register this particular flow over there. And you see that it not only it ran, you saw some logs coming out of it. And you also saw a hello message printed from this particular application here too. Let's find this in the Prefect server. We said that yes, it has registered itself, right, in the Prefect server. So it ran a flow over here. So let's copy this. Let's copy this. And follow this link and let's see what happens. So it comes up with these funny names over here. So like a two worded names, so mutant dog, and you will see it comes up with all these funny names. But the flow that we have is same message flow, and this is one of the runs for it. And it actually ran over here is what it is showing, that there's nothing to show exactly. You did not return anything from the flow. So there is nothing captured over here either. But all that is showing over here is that a run was done. Before we proceed, maybe it will be useful for us to delete all the previous runs, right? I'm gonna get rid of all the previous runs from my server over here. And let me see if there is anything over here from flows. I'm gonna get rid of all these flows. And I will get rid of all the runs because all the flows are gone. I'll get rid of any deployments, worker pools. That should be fine. And okay. Okay, all right. So we are starting with a clean slate so that there is nothing to see over here. And we will run our code again so that you can follow along and you will have the exact same code base as we do. So we're gonna run this code again and we will see this register in our Prefect server. There we go. So we run it again and we will see this getting registered in our Prefect server. I'm gonna refresh this and you will see that there is one flow run over here and it come up with a new name. But not only can you see this in the dashboard and click over here, but you can go to the flows and you can check this over here too. So I'm gonna go to flows and you can see that there is a say message flow. And if I click on this, it shows me that there is one run of this flow. Prudent taper is what it came up with. And if I run it again, right? So let's run it again a couple more times and you will see what are the instances of the flows, right? So I'm gonna run it again and refresh this and you will see that there are two instances of this flow runs. One was the previous one, prudent taper, and this is offbeat kingfisher, the new run that it came up with. Right? I'm gonna run it like a couple more times so that you guys know that every time when you run a flow, right? So fair alligator, this is one more, and let's just run once more over here. And let's go back, let's do a reload, and you will see that all those 4 runs are registered as individual runs. And this is the beauty of it, that you have all the logs now with you. So once you have finished running certain flows, you can go back and you can visualize that all those 4 flows were actually executed and everything in there you actually have a log of. Right, so let's explore one of these flows. If I click on this, the latest flow over here, you can also see this from the latest one on this particular timeline window. If I go to the latest one, click on this Jasper one, you will see that there is a log which says it is finished in the state completed, but there is nothing else in here. There are no task runs. There are no subflows, no artifacts, and then some details over here, no parameters, and it's kind of empty flow. So this flow, even though it did run, it did nothing. Let's change that. In our next example, we will create certain tasks and we will designate those tasks to be in this flow. So let's go to second example over here, example 02 flows and tasks. So you'll see that in this example, what I'm doing is I have a task created, right? So first I'm importing flow and task, 2 different things from Prefect. And these are the 2 decorators that I'm going to be using. So there is a message, a same message task that I'm invoking from a say message flow, right? So actual execution of the business logic. In our case, the business logic is very simple, but actual execution of the business logic does not happen in the flow. the execution of the business logic happens in the task. So from the task, we are doing an activity, and from the flow, we are just invoking a task. So that's how that demarcation line is, that we will call a task from a flow, and a flow will have multiple tasks in it. But let's start with a simple example, and you will see that a flow over here is configured to accept a parameter, right? And a task is going to be passed along with this parameter. So the way this will run is we'll invoke the flow will invoke the task, and by the virtue of this task being marked as @task over here, it will show up as a task on our Prefect server, right? So let's do two things. Let's delete this task over here, and let's run this particular flow once, and then we will add the task on top of it, and we'll see how it changes, right? So let's go ahead and let's run Python 02 tab. So we're gonna run this particular flow now, and I'm gonna hit enter, and you will see if we go back to our flows again, so there is a same message flow, and there is a third instance of it now over here. Well, fifth instance of it, the one with a parameter, because you remember in this case, this flow is accepting a parameter now, and that's why it is saying that there is a parameter over here, and all previous flows that we had run 4 times did not have a parameter. So let's take a look. If I click over here, it says, finished in the state completion. There are no task runs, even though we are invoking a method from the flow. It is not registered as a task. It is just a regular Python function. Let's change that. We want to have this thing as a task over here. So if we register the method, the Python function that is being called from within a flow as a task, now this gets designated as a task. I'm gonna save this and run this again. So if I run the same file again, now because this particular method is being registered as a task, the same information gets passed along to our Prefect server as well. So you'll see that a task run, and it came up with its own funny name again, a task run was also done on top of the flow run. Let's go back to the Prefect server and visualize that. So I'm gonna go back to flows over here and same message flow again. And you see that this was the previous run with no tasks in it, and this is the new run with a task in it. So let's open this and let's visualize it. So now it says that, hey, these are the few logs. It finished in the status of completed, of course, and created a task run over here. And so let's go to the task view, and there we go. There is our task. So if we go to the task, it says that, yep, a task was also run over here. And these are the messages that are coming out of the task. So the tasks states and the flow states, everything you can now see. So this is very cool. Let's summarize what this particular flows and tasks mean. So flow is just aggregation of multiple tasks together, right? In this very simple example, we just have one task, but in general, you will have multiple tasks in a flow, which is what we are going to take a look at next. So if we have multiple tasks together, how do those tasks show up on our Prefect server? So in order for us to do that, let's close our basics section over here and switch to the synchronous and asynchronous concepts, where we will have multiple tasks together. So whenever we have multiple tasks, we want to know that, hey, are the tasks running in parallel? Are the tasks running one after another? And if there are some tasks that we want running in parallel and some tasks running sequentially, then how do we do that? So let's take a look at that in this next example over here. So this is the second folder. So I'm going to go a folder level up, which is B, async concepts. And let's open this particular async file. And I'm going to pin this and close others. All right. So in this example, what I am showing you guys is that there are three different tasks. So this is an example where I'm taking use case of a generic use case of user notification flow, right? And in this user notification, there are three different tasks. Task number one is greet user. Task two is provide status update. And task three is fetch account balance, right? So there are three different services that do three different things, and then they can take different amount of time when they are executing, right? So in our flow, what we are trying to do is execute three tasks, and all the three tasks are going to be executed one after another in this current flow. Why? Because there is a synchronous operation that is happening on here. And let me run this code, and then I will talk about it, what is happening in the background, right? So let me go and run this code. Python, and this is 03. And I'm gonna execute this code, and then we'll talk about it, that what's going on in the background. So let me hit enter, and the flow is being run. The first task ran, and you'll see the second task ran, and then the third task, fetch account balance, ran, and then the flow is completed now, right? Let's go back, take a look on our Prefect server, how this looks like, and then we'll talk about what happened in the background. So let me go back to the flows, and you will see there is a new flow showing up over here now, user notification sync flow. So let's click on this, let's visualize it. So if I come over here, and if I click on this particular run of the flow, then you will see that these are the three tasks that are listed down over here. But the way these tasks are, they are running one after another. Why? Why are they running one after another? So let's go back to the code and take a look at it. So there is a time.sleep operation, which is a synchronous operation. So this is causing the first function to execute, and then because we are having a synchronous operation over here within our method, it is blocking that execution till it is done. And then we are calling the second provide status update. It is blocking it again for time.sleep 3 seconds. And then the third one, which is blocking it again for 5 seconds. So if you see over here, these methods are executing in a sequential order over here. So the first one got executed, then the second one got executed, and then the third one got executed. And a beauty of this is if I run this whole thing again, I'm gonna come over here and reload, go to the user notification flow, and this is the first run of it. I'm going to be executing this again, the same method again, so you can visualize it on the fly, how this looks like in the Prefect server. So the first activity has a 2 seconds of simulated delay, the second one has 3 seconds, and the third one has 5 seconds. And in the user notification sync flow, the way I'm calling this is, I'm calling the first one, greet user of 2 seconds delay first. Delay is just, simulating. Let's say it's going to a database, getting some information out. So I'm just simulating an actual delay that is coming from a database over here. Then provide status update, again the same story over here, and then fetch account balance, the same story over here. So 5 seconds of delay in the third one. And then I'm aggregating all of that data back and then returning it out of the flow. So the return from the flow is actually the final return that is registered as the result from the flow too. So that's something that will come into picture in the later advanced concepts, but please keep that in mind, that the return from the flow is the result from the flow that we can store in a dedicated place later on too. All right. So let me run this again, and I'll switch to the Prefect server. So this is running over here. I'll switch to the Prefect server, reload. This is the new run. I'm gonna click on this, and you will see on the fly, you can see how these three different activities are run, and then they are shown over here. This is pretty awesome. This is so cool. So not only that, you can see these activities being run on the fly, and you can see the execution times. It shows you 2 seconds which is a smaller execution time, 3 seconds a little bit bigger, and 5 seconds longer than all of that. So it is pretty cool to visualize this too while a flow is running over here. All right. Now let's take another example. What if you did not want these flows to run in sequence, but you wanted them to run in parallel, right? So even though they have synchronous blocking, like time.sleep function in there, you do not want all of them, let's say, to run sequentially. You want them to run in parallel. So what you've got to do is, instead of just running the method, you have to submit the task, right? So the greet user task needs to be submitted to Prefect, and you're getting these submit because you have already decorated this as a task over here. So that's why you are able to get the submit functionality on this greet user method, even though you haven't implemented it, right? So that's where the Prefect takes care of it by its task decorator. So now all you're doing is you are submitting it to the Prefect server, and you will let Prefect server run all three of these tasks in parallel. Let's visualize this. So I'm gonna run this now. So Python 04, this is the fourth script, and you will see that all the three tasks over here, they all got submitted at the same time, and then they will finish at different times, right? So let's go to the Prefect server, and let's go to the flows. Let's go to our user notification async flow over here. And let's run this, visualize this, and you will see that all three of them got run exactly at the same time. They finished at different times, yes. So the first one took 2 seconds, the second one took 5 seconds, and the third one took 3 seconds, but they were all scheduled at the same time. And because they were all scheduled at the same time, there's no guarantee, right, that they will show up in the same order over here. They're all scheduled at the same time anyway. So as soon as the request came to submit, ploop, 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 all three of them got scheduled at the same time. All right. Now, let's visualize this too. So I'll hit this again, enter, and then I'll come back as fast as I can, and hopefully I'll catch it running, and you will see that we can visualize the flow too. Again, the same story. The more you run, the more instances of these runs will show up over here, and you can, if you go to a flow, this is the async flow. You can click over here. You can see the 2 runs of this particular flow that we have done, and it shows up over here too. All right. While we are here, there's one more thing that I can show you, that you can execute these flow runs directly from your runs over here. So let's say you have any particular flow run already, right? So let's go to this flow, let's go to this async flow, let's go to one of these runs over here, and then if you press on this 3 spots over here, I'm just gonna try to find. So I was trying to find an option to run this, but of course, I'll have to wait on that one till we create a worker, and then we are able to run this on a worker. So let's hold on that particular aspect of it. So there's an option to run a flow, but that of course won't show up right now because we cannot force run the flow because there is no worker yet, and all these things will come together in a few minutes. All right, so let's go and take a look at an option where we want to have a mixed scenario where part of the flow we want to execute in parallel and part of the flow we want to execute sequentially, right? So we want to have a mixed sync and async scenario. So in this case, we have 4 tasks now. First task is fetch user info. Right? So you are just getting the details about a user. The second task is check account balance for the user. The third task is send a notification to the user, right? So it's like simulating an email. And the fourth is update user preferences, right? And they all have different kinds of time that they'll take. So let's say the user info task is taking 2 seconds, account balance is taking 3 seconds, sending a notification is quicker, so it takes just a second of time, and user preferences takes, let's say, 2 seconds of time. So now let's demonstrate how you can have a sync and async combined together. So whenever you execute a task's result method, right? So whenever you say, hey, I want to execute this task, but I want to wait for its result. As soon as you say that, the task will wait for the result, meaning it will block it. It becomes a synchronous activity now. So you can spin up these tasks as submit, which is all right. So the very first task is being submitted to the backend, to Prefect server as, yep, executed, parallelly to all the other tasks. That is fine. You submitted it. However, whenever you have called a result on that particular task, so now this becomes a blocking activity because it will wait for the final result before the next submit of this can be done, right? So check account balance dot submit cannot start unless and until the user info dot result comes back, which is a blocking operation, right? So what that means is that this activity needs to be done first before this submit can be called. So we have made a sequential operation over here. Now, notification task is dependent on the balance task's result. So this cannot happen before the balance task's result is found, right? So this is dependent on this task. So internally, this is dependent on user info too, but you do not have to spell it out. You can just say that I'm submitting it. However, till the balance task result is back, you cannot proceed. So it's gonna wait for the result of the balance task activity. And then preferences task is the same story, but it is dependent on the user info task. So 2 tasks will run in parallel, right? So balance task and preferences tasks will run in parallel. The very first task to finish will be user info task. So first user info task will finish, then balance and preferences task will run in parallel, and then once the balance task is done, then notification task will run right after that. So this is how we can have our sync and async operations done in conjunction to each other. So let's run this, visualize this on the Prefect server's UI, and then it will make more sense. So Python, and this is 05. And I'm gonna hit enter over here, and let's visualize this on this dashboard, and you will see that fetch user happens first, and then check account balance, and then the other tasks in this order in which I have explained get scheduled. So let's visualize this. It's easier to visualize on the Prefect server, and let's go to the flows. Let's refresh this, and there is a user notification, user account flow. 604, this one, yep. So user account flow, and over here, let me click on this. And you will see that the user notification, the fetch user info gets done first, check account balance gets done after that, and then update user preference and send notification, these two run in parallel. So there are certain activities that are dependent on certain other activities, and then 2 other activities can run in parallel. And this is what has happened over here. So this is awesome. Now we have the ability not only to run things sequentially, not only to run things parallelly, but we can have a mix of both sequential and parallel runs, right? So update and send notification ran in parallel. Let's take a look at that again. So there is notification, send notification, and update. They ran in parallel over here. So let's see. Update and send notification, these two ran in parallel, and fetch user info and check account balance, these ran sequentially, and everything, these two ran after check account balance, right? So check account balance blocked the, so check account balance over here has blocked the execution whenever we will do check account balance dot result, which we are doing balance task dot result over here. So balance task dot result will block the execution of check account balance, and your preferences task can run in parallel after user info over here. So fetch user info dot result. All right. All right. So I hope you guys can see what happened over here. So because the way it is written sequentially over here, so user info, of course, user info is the first one to run, but it is submitted parallelly. Like it is just submitted to the task engine. The second one is the check account balance dot submit, but it is blocking based on the user info's result, right? So this will definitely run after the user info. So if you see over here, check account balance, this will run after user info, which makes sense, right? The third activity was send notification, and this is waiting for the balance task, right? So send notification, this is waiting for the balance task over here. And the preferences task, even though it is dependent on user info.result only, it waited till the send notification one over here. So if you see, so it waited over here till your send notification one, which was dependent on the balance task result, right? So because we had asked for the balance task result before it was blocking this time period over here, right? So it was blocking this particular line number 35 for the balance task results, and it did not queue the update user preferences after that, right? So if you see, update user preferences ran at the same time as send notification because the check account balance was blocked by the previous operation even before it can be queued. Let's take a look again. So on this particular line, because the balance task has a blocking behavior over here, balance task result is being waited upon by the notification task, and this cannot be queued up until this line is finished because this is already waiting for the balance task result, right? So even though it says very clearly over here that, hey, I only need the input from the fetch user info, right? And it is available. It waited till the check account balance is done, right? It waited till the check account balance is done because it could not be scheduled over here. So I want to make sure that this is clear, that even though they are submitted, it will still have the blocking behavior because you have asked on line number 35 to wait to go to line number 38 till this line is executed over here, right? So this is why it is the blocking behavior that we can see. All right, but visualizing all this in real time also helps us in clarifying certain doubts that we have, and it really helps us in mapping out the whole flow. So that, let's say if you created all these tasks, right, and then you executed them, and then you were not able to figure out that, hey, why isn't one task running in conjunction in parallel to another task, right? So you can reason it through once you see everything, laid out in a nice visual format, which Prefect allows us to do. All right, so this is the sync and async flow that we have. Now let's come to a very cool topic in Prefect, which is retry logic. So in order to go to retry logic, let's go to the folder that has the retry logic code in there. And I'm gonna close all this and open the retry logic code. All right. For retry logic, the concept over here is that if something fails in the execution of a task, and if you want to have an ability to retry, you do not have to build in your custom code to do that. Your task decorator will let you do it. So let's say while fetching the user info, while fetching the user info, if your connection to the database failed or your API call failed, right? And you just want to retry it with exact same parameters just so that you you overcome those random failures to an API call. So it's very easy to do all this in Prefect by just building your retry logic in the decorator itself. For example, let's take a look over here. Retries equals 3 and retry delay in second equals 5. What that means is it will retry up to 3 times with 5-second interval between 2 retries. And if it fails after 3 retries, then it will give up, right? But it will at least make 3 attempts with the same input parameters to do a retry. So the way I'm doing this is I'm just randomly causing this to fail. So this particular method, I'm just randomly choosing it to fail so that you can hopefully see during the run whether it is attempting a retry or not, right? So I'm just gonna run this particular flow over here. And so in this flow, almost the same thing that you saw previously is happening. I mean, we have the sync async mixed scenario where the user account balances, user info is fetched first. But while fetching the info info, right, there is a randomness built in there where it will just randomly fail. Right, so it will raise a failed run, and because of this failed run, it will attempt to now retry it. It will raise an exception over here. All right, so let's run this, and this is your 06, Python 06, and we'll run this, and oh, awesome. So it failed, and because it failed, it will wait for 5 seconds. It failed again. That's awesome, right? So it made 2 attempts, and in both attempts it failed. And in the third attempt, luckily it passed, right? So it went through, and then we'll see how it looks like on the UI. So we'll see 2 failed runs, and we got lucky over here with 2 failed runs and the third passed run because we are just randomly choosing it to fail with a 50% chance of pass and fail over here. So let's take a look. So we'll go to the flows, and we will go to the user account flow again. And this is the latest flow, 17 seconds it took. And it's, oh no, this is not it. Let me reload it. Is this the right flow? Let me take a look. So user account flow and Quick's toxic shrimp. This is the flow. Okay. So let's find that flow. User account flow, Quick's toxic shrimp, and task runs. Why am I not seeing the failed runs? Oh, there it is. There it is. Okay. So if you see in the task run, in the logs over here, there was a failed exception over here, then failed again, and then it finished in the third attempt over here. So let's go to the task runs, and I want to see the fetch user info. This is where the failure was built in, and let's go inside there and see. So it says that it failed, and then it finished after that. So there we go. Now let's also come over here. I'm going to reload this, and I will run this again and try to visualize this over here on the fly. So let's see this. So this is a run. Oh, so it passed the very first time itself. So we got lucky over here. Okay, let's run it again, and hopefully it will fail for us. Let's go to the flows fast enough if we can catch it. Yep, so it failed, and you can see it was orange over there, and then it passed the next time. And then it passed over here. So we haven't built the failure criteria in here, but only in here. And you can see when it takes longer, it's because it waits for a little bit before it runs again. And that's where you see that orange state that it is waiting to retry, and then it is retrying, and then whatever the next status is, which is completed. All right, so retries are simple to implement, but they are very powerful tools that are available in Prefect. Let's go to the next concept, which is very simple, basic concept, but it's very useful. So there is a logging concept over here. So in Prefect, you can add some logging by doing the get run logger, right? So you can get the run logger from Prefect, and you can do some more logging, and you can visualize those logs on your Prefect server UI. So it's very simple concept, but let's just demonstrate that how we have utilized it. So there is a logger over here, and we can do logger.error, right? So you will see some better logging when we are visualizing this on the Prefect server. So you remember in the previous run, even though there were some failed logs, it was harder for us to visualize them because it wasn't showing up specifically standing out saying that it is failed. So let's hope that we will see some better logging using this particular logging mechanism now. So I'm going to run this 07, Python 07, and let's go over their flows, user account flow. This is the currently running flow, and unlucky for us, it didn't fail over here. So let's run this flow again and hope that it fails. So let's go back, flows, user account flow, this one, and it did not fail, looks like. We have to probably increase the randomness over here so that it will fail. Let's try that again, and let's hope it fails this time around. All right, it didn't fail anyway, that's fine. We can still see, so if it fails, it instead of info logs, it will show you the error logs. I really want it to fail, so what I'll do is just run it once more, and yeah, there we go. All right, fourth time is the charm. We got 2 error messages. Wow, so that is really nice. And then it passed next time around. So this is awesome. So now you can see that once it actually fails, because you have raised the log.error message, it will highlight it in a different way instead of sending everything as an info, right? And you can see all these things in the task notification. Oh, it's the wrong run in the run tasks for fetch user info. And you can see in fetch user info, the error messages being raised over here too. All right, so this is very powerful, simple yet powerful feature of your Prefect server that takes care of retries and of logging. So now let's just take a very simple example of sync async flow with the random failure built in. And let's just visualize the original example that we were taking a look at, right? So we will run this 08 file now. And this is both sync, async flow, retry logic with logger all in one example that I have here for you. So if you see in this case, we are checking for account balance using. So there is a simulate failure of 0.3 probability over here. So 30% of time the tasks will fail. And there is a retry delay of 5 seconds. And we will simulate a failure by calling the simulate failure method. And if a failure happens, then you will just retry. And that is what we are going to see in this particular example. So let's run this. Gotta hit enter to run this. And we will go back to the flows. And this is the flow that is running over here. And there we go. There's a failure that happened over here. And I think we do not have any kind of retry on this particular one. Otherwise, it would have retried. I don't see any retries. So let's take a look if we have retry built in for update user preferences. So let's take a look. There is no retry built in for update user preference, and this is the reason why this happened. So the easiest way to build in a retry is you can just copy this, retries equals 3, and just put it on this particular update user preferences 2, and you can run this again. And let's see if this particular flow fails again. And if it does, this is running over here. And there you go. There was appears to be, I don't know, I'll double check. So let's see. Oh, there was no failure over there. Okay, all right. It just ran. It just ran perfectly fine because there was no failure. Okay, but all I'm trying to show you over here is that adding a retry logic on any particular task is very simple. You just add the retries and you add your retry delays in seconds, and then you can have a task being attempted to retry it. All right, so all this shows you if you have a Prefect server locally, and if you're trying to run everything locally on just one particular server, with your flows and tasks, retry logics, exceptions that you are manually raising or that you are catching from some other APIs, and then you are logging them and all that, right? So this is cool. But what if you have your Prefect server remotely deployed, right? So we can still simulate all that in our local environment over here, but what if that Prefect server was remote somewhere else? Then what do we do? So in the next section, we will talk about deployments. And deployments is a very important concept in Prefect. What deployment does is it packages your flows into a configuration.yaml file, and it helps you in deploying it to a server. And not only you can deploy your configuration to the server, but in that configuration, you can mention like where your code is, where do you want to store your results, and the idea is that you do not want to keep, even though you do not want to keep your code also on the Prefect server. The Prefect server will only have a high-level configuration details of where your code is, right? And it will run the code wherever the code is, but it won't get the results back if you don't want it to save it, right? So you can configure the Prefect server to do all that, but in terms of separation of concern aspect of it, Prefect disables a lot of things by default, and then you have to enable it in order for you to see certain aspects of things that Prefect is logging. So let's go visualize this in code, and then all that I'm talking about will make more sense. So let's switch to this next directory over here for deployments. I'm going to close all this, get them out, and let's do a deployments section. So like I said, deployment is a packaged version of your flow. Along with its configuration, flows, schedule, and some metadata around it, we package it all into a deployment YAML file. And this allows you to trigger flows with specific settings and even run them on different environments. So think of deployment as a way to take your Prefect flows and then put them on an autopilot. Right. So as a quick breakdown, the code is the flow that you want to run. Right. Configuration is the environment setting, parameters, schedules that you want to apply to the flow and all that, and trigger is the deployments that allow you to trigger a flow. Right, so you can trigger a flow using some schedule or using an API call, but deployment will enable you to do that too, right? So they will enable you to trigger your flows as well. So let me show all that in action now. So I'm going to go to this deployment section, and I will just take a simple user flow over here. So coming back to this, in this flow, if you see, it's a very simple flow where we are simulating to fetch user info, and we are we create one flow, user account flow, and then we are just getting that information of the user details from a task called fetch user info, right? So it's a very simple rudimentary example, but it will show us how we are going to use deployments for this. So number one, just to make sure everything is working, we will go in and run this flow, right? So let's do our regular Python, and the name of this file is, let me close other files over here so it's easier to visualize. So the name of this file is userflow.py. So userflow.py, and this will go and register itself in the user account flow. And the run is Coral Tamarind, right? So let's go over here and let's visualize this. So flows, user account flow, and Coral Tamarind, and you'll see that this just one single task over here and the flow executed. Nothing special about it. There's a task run that you will see, and then there is a log for it. So nothing special about it yet. Now let's create a deployment for it. And if we create a deployment, then we will need something called a worker also for it. Now, what are workers? So workers are actually the unsung heroes of Prefect. So while deployments will package your flows, workers are the engines that execute them. So they are the infrastructure essentially, right, that picks up your scheduled tasks and run them when required. And they can be configured to run either on your local machine. I mean, in our case, we do have everything running in our local. So we'll set up the server and the worker both on our local machine. But think of it like this. If a deployment is a to-do list, worker is the person who picks up that list and completes the task, right? So there are different types of workers. I mean, you can have a local worker, which is what we'll be playing around with today. You can have a Docker worker, which is ideal for most isolated and containerized environments. And then you can have Kubernetes workers, right, for large scale distributed tasks across the whole cluster. So now let me take you through to the code and then explain about deployments, create a deployment, create a worker, and all this will then fall into picture together. So up until now, all we have done is we have ran a flow on our local machine where the Prefect server was also installed. And then because we are running the flow on the same machine, it is configured to have the Prefect's API and Prefect's base URL. And then it just registers it and it just sends it, on the same Prefect server. Let's change that. Let's create a deployment over here. And in order for us to create a deployment, so I have also written a README file over here for you to take a look at how you would run it, and a basic example from my console is right here. But what I'll do is I'll go over this process with you so that you can visualize this too. So let me clear the screen, and let's just do as simple as this. In the same folder where your flow exists, just do prefect deploy, right? And make sure that there is no previous YAML file in here, right? So if there is any previous YAML file, just delete it. Make sure you only have your flow in there, right? So just prefect deploy, and it will guide you through the process of creating a deployment file. And let's do that. Let's do that on here right now with me. So it scans your project folder and it sees that, there is a user account flow, and then there is a user flow.py over here, right? That is awesome. So it's asking, is this the one that you want? Or do you want to enter the entry point manually? Nope, we just want this, the user flow.py. So entry point is, so let's say if you have multiple flows defined, which flow do you want to have as your entry point? In our case, it's a very simple use case where we have one task and one flow. So we know that this is the user flow over here. But if we had multiple flows defined over here, which is the entry point? There has to be one entry point that this file will be executed with. So we are choosing user account flow as the entry point over here. All right, so I'm gonna hit enter over here. And then it's asking, hey, what do you want to name this deployment as? And if you just hit enter over here, it will choose default as the name. Or you can actually define a name over here too. So let's say user account deployment and test, right? So anything, I'm just putting up a name over here. And then you hit enter. It's asking, do you want to configure schedules for this deployment? As in, do you want to run it every hour, every minute, every day? Is there a schedule for it? No, not for us. I'm just going to choose no over here and hit enter. And then it is asking, what worker pool do you want this particular activity to be picked up by? So we can choose the default worker pool over here. We do not want to create any fancy worker pool. It's just gonna run on the local infrastructure in the default process over here. So we're just gonna choose, because we're running everything locally over here, I'm just gonna choose this current default process and I'm gonna hit enter. And then it's asking that, do you want your flow to access the code from a remote infrastructure somewhere else, right? No, we do not. We do not want all that. Our code is all locally available over here. We do not want it to go out and fetch the code from a remote repo. So I'm going to choose no and continue. And now you see that it has created a deployment and it has successfully injected it. And we will go take a look in our Prefect server, but let's also finish up with this final prompt over here. And it says, hey, would you like to save this configuration for this deployment for faster deployments in future? So let's do yes. And once you do yes and hit enter, you will see a YAML file that is being created. And if you had chosen no over here, there will be no YAML file created, and that's okay too. But if we do a yes, it will create a Prefect YAML file, which we can take a look at in a few minutes. But before we do this, let's quickly go to our web browser and look at the deployment section over here and see if anything has changed. Awesome. So it says that there is a user account deployment test, which is the one that we created over here. Let's refresh it. And then it says that it is available. Some aspects of it in the deployment right here. So there is a deployment now created for it. However, in this deployment, number one, it says not ready, right? We'll address that in a second. And also there is no worker pool over here, right? What does that mean? So let's say if we run this deployment, right? If we do a quick run for this deployment, it says it is scheduled, right? It is scheduled, but where is it going to run? There is no worker in this pool available, right? There is no worker available for it to run. So how do we actually run this code base? So in order for us to do that, we will have to start a worker pool, right? So let's start a worker pool, finish up this particular deployment, and then let's talk a little bit more about it, as in what is happening in the background. So in order for us to start the worker pool, so we had said that we want to use the worker pool of default, right? When we were configuring the deployment. So you can use this worker pool of default, and you can create by running this command, or you can just do prefect worker start, and it will guide you through the process of which particular worker pool you want to create. Let's do that next. So over here, we will do prefect worker start, and it is gonna ask you that, hey, what's your worker pool name? And default is what we had chosen earlier. If you see, it is actually giving you the command right here. You could have just chosen this, or you can just do prefect worker start and hit enter, and then you will see that your worker is started now. Now, if we go back and if we take a look, you will see that your worker pool is available, your default worker pool. If you go to deployments, it says it is ready now. And not only that, it actually did run this particular scheduled run that you had, right? So it was unavailable because there was no worker pool available for it. So it kept on saying not ready, even though your deployment has been deployed. Because there is no worker pool associated with it, it kept on complaining it is not ready. If you initialize your worker pool, it gets associated with that deployment, and it gives you an indication that it is ready. All right. So let's shut down this particular worker pool. Let's go back over here. Let's reload this user account flow in the deployment over here. And it says that there was one registry of that worker pool available, because of which it will say that it is ready. And if I go over here, scheduler run, quick run, now, even though it acknowledges that, you see it is not going to run. There is no worker pool available for it to run. So it's just gonna keep this particular run as scheduled, and it'll just stay over there. You can have multiple runs of this deployment, right? So you can go over here, you can run it again, and you will think, why isn't it running? I keep on running it. It just keeps on getting scheduled, right? But it is not really running it anymore. So what's going on over here? So it even says that it is late. It is late over here. It is not running. And if you come back to the deployments, it says now it is not ready, because it has caught up now, right? It has caught up that, yep, there is no worker pool anymore. So what do I do? So it kept on putting the previous runs to late, and any future runs are just scheduled now. So what is going on? What is this worker? And you remember, while we were creating this deployment, it had also asked you where your code base is, right? So how is it picking up your code base right now? So let's take a look at the deployment YAML file that has been created, and then we will start the worker pool, and then we will see how this code is getting picked up, and we'll put all those thoughts and pictures together. So this is the YAML file that got created during the deployment. So what we are saying is that the name is this, doesn't matter, prefect version is all that, right? All this we do not need to worry about. Now, this is where your workers, your deployment's working directory is, right? So this is where the working directory is. This is the name of the deployment that we have chosen. This is the entry point of the deployment. If you recall, this is the user account flow that we chose as the entry point, and the worker pool name is default. So these are the configurations that we have for our deployment.yaml file. Now, as soon as we will start this particular worker pool with the name of default, it will match it with this deployment. And because this worker pool is associated with the same prefect server with the name of default worker pool, it will pick up that particular task that is scheduled right now, the flow that is scheduled right now. The idea being you can have multiple different worker pools with different names, and those worker pools can be dedicated to a particular task, right? So let's say there's a very critical task or a critical flow that you do not want to be shared across different worker pools. It's such a critical business flow, for example, order export cron job, which exports your order, right? And you want a dedicated worker pool for that particular cron job, right? So you can create a flow, and that flow will only be executed on that particular maybe scaled up worker pool, right? And then there are certain other worker pools that you can segregate, and they will run different kind of flows over there. So let's start this worker pool again, and it will ask what's the name of the worker pool. You can choose the same worker pool name that is specified in your config YAML file. And then as soon as you hit enter, you will see that it picked up all those tasks, and it is going to run all those tasks, right? So it realized that, oh, there are a ton of tasks waiting for me. If you reload it over here, you will see that all those tasks that were waiting, they got fetched by that worker. And as soon as the worker came live, it pulled all the tasks from the Prefect server, from the deployment queue, and then said, oh, yep, I know I was down, but now that I am up, now that I have connected to the Prefect server, I'm going to run it in the order in which they were queued and scheduled, right? So this is such a nice feature that is available. Now, if you see, I have been running these tasks from the UI over here, right? So I just schedule it from the UI, I hit run, and they are getting picked up by the worker, and they are getting run. It is not run by the Prefect server is what I'm trying to say. It is run by the worker. Worker has access to the Prefect server, which just gets some configuration details that get passed on to the worker. Worker sees what it has to do and then executes the code over there. So the worker has access to the code and some more information. The Prefect server just has access to the configuration, which is passing on to the worker and telling it to execute, right? So this is a very important concept over here, that if the worker is down, if you do not have your worker connected to your Prefect server, nothing will happen, right? You can keep on scheduling your tasks, right? Those tasks will be scheduled, and you will know when you schedule those tasks. Nothing will be run unless and until a worker is up. And this is a feature. This is not a bug. This is by design. It is designed in this distributed fashion such that your Prefect server maintains the configuration. Multiple workers can connect through a worker pool to the Prefect server, and they can start executing the tasks. All right. So all that being said, let's move on to the next aspect. So there is a concept of parameters in deployments, and we will talk about that next. And we'll also talk about the API triggering a particular deployment by an API, a particular flow by an API. So let's say if you have deployed something in your Prefect server, if you have deployed a flow in your Prefect server and you want to trigger it by using a REST API call from anywhere in the world, right? You're not on your same machine, you're on a remote machine, and you just want to send an API request to a Prefect server that, hey, I want to schedule a run. Can you run it? And not only that you want to schedule a run, but you also want to pass in a parameter while you are scheduling a run. And that is the use case that we will see next. All right, so I'm going to kill this particular worker over here. And what I'll do is I'll split the terminal into half on the right side over here. And I'll start the worker in this terminal, right? So I'll do a Prefect worker start. And I think let's just start like this. And we'll just validate if this is working fine by running our user account deployment test over here. So we'll go to this deployment, we'll do a quick run again, and we'll reload, and there you go, and completed. All right, so this worker that we just started was able to pull the task and complete it. Perfect, this is what we want. Now, let's go to this. Let's close all these extra files that are over here. Let's go to this E directory. So cd /e. And let's take a look what's in here. So there are a few files in here. The one that we are interested in is this user account balance.py. So I'm going to click on this. And let's take a look at this again now. So we have seen this file. We have seen how we have fetch user info, how we have check user's account balance as another task, how we have send notification task, and how we also have update user preferences task. So there are 4 different tasks over here, and you'll see we have retries put on each and every task. So this is like an all-in-one example that you're gonna see. And you have logger over here too, so you can have some logging messages. You have simulated failure, so there are different failure rates that I have applied over here. 0.2 for this method, 0.1 like 10% chance over here, 20% chance over here, right? And 30% chance of failing this API. So the idea is that, hey, you know, it's a real world scenario. We are fetching user info, we are checking account balance, we are sending notification, and then we are updating user preferences, and we are doing it in a sync and async fashion. So same thing applies over here, right? So these operations are blocked. Some of these operations, some of them are happening in parallel because we are submitting it to the task engine, and we are not actually running it, executing it directly. So all of that is happening over here. What's the difference then? The difference is that we are going to be creating a deployment for this, and we will be calling this deployment using an API call. So instead of going to the UI in the Prefect server and clicking on the run button, we will be calling the deployment using calling the flow, a deployed flow, using an API call to the Prefect server, which is what we will do now. So even before we do that, let's go to the deployment page and see there is only one deployment available, user account deployment test. Now we are going to create another deployment, right? And that is going to be done using prefect deploy command. So we are already in this parameterized deployment workers folder over here, right? So in this particular folder over here, and what we'll do is we'll do a prefect deploy, right? And doing this will ask you that, hey, what is your flow that you want to deploy? In our case, it's just one single flow, user account balance, and we'll just hit enter over here. It's asking what is the name that you want to keep. So I want to keep the name as, let's say, user account balance, right? So this is the name of the deployment that I want to keep. Let's hit enter over here. And would you like to configure schedules for this deployment? No, I do not. I want to trigger it using an API call. I don't want to have any kind of schedule for this, so that's all right. Now, do you want, what worker pool do you want? So you see on the right hand side, we have the default worker pool over here, right? So we choose the name as default, which is the one that we want to use over here too. So we're going to choose default again over here. So let's hit enter. And then it's asking, where is the code? So code is all locally. We do not want it to fetch it from any remote location. So I'm going to say no. Just do everything locally over here. And then it's asking, hey, do you want to create a YAML file for this? Let's do a yes over here, and let's have it create a YAML file. However, it has already sent the deployment to our Prefect server, so it will be available over there too. So I'm going to just do yes, and it has created a deployment for us, a YAML file for us, and we will take a look at this YAML file now. So if you see in this YAML file, you have your entry point specified, you have your deployment name, user account balance specified, and everything looks just perfect over here. Now we're gonna go to our deployments, and there is a new deployment right here. And the reason it says ready is because our worker is associated to it already, right? So the work queue of default is associated to it over here. And if you want to run this, you can trigger it manually as always, but there's something special you'll see. If you click quick run, it's asking for the user ID as a parameter, right? This is what a parameterized deployment means. So in the previous test run, there was no parameter. And in this one, you do see a parameter y, right? So let's go back over here. In this particular one, when you were hitting run, quick run, you did not see any parameter over here. But if you go to user account balance, you hit run, quick run, and let's just say 1001 or whatever over here, and then you are able to run it. So there is a parameter over here. Let's see why that happens. And I'll let this finish too. Come on, it's scheduled now. It's pending, which means it is running. It has been picked up. It is running. You can see the running status. And very soon, let's take a look at it too. And should be finished soon. Yep, so it is done now. It is completed. Okay, let's take a look at the code and then come back over here. So if you see the previous code over here, user flow, if you see in this particular flow, there is no parameter. Why? And let's come over here. Where is our file? There, user account balance over here. And you see that there is parameter associated to the flow. Where is that parameter and how do we associate it? Let's take a look at that now. And in the code base, we'll see over here. Let's see. So there are two things that we want to talk about. One, does the flow have a parameter that it accepts? And two, whether it has a default parameter that has been assigned to it, right? So if we take a look at the previous flow, there is the flow that accepts a parameter and there is a default parameter assigned to it. So you can either do a quick run with this flow and that will accept the default parameter and continue with the run. Or if we go into this example, there is a flow, accepts a parameter, there is no default value over here. So if you do a quick run with this flow, it will force you to enter a parameter. So in reality, both the flows are parameterized. It just happens that this flow, by the virtue of it not having a default value, it is forcing you to enter a parameter over here. Let's visualize all this on the Prefect server. So let's go over here. Let's go to the deployments. In this particular deployment, which is corresponding to our user flow. So that deployment over here. One second, let's pull this up. So this user account deployment test corresponds to this user flow. And you will see that this user account flow has user ID 101 as a default value, right? So let's go back and look at it. If you click on run in the quick run, it just lets you do it. It just lets you do the quick run, right? You do not have to specify the parameter over there. And if you go to this parameters tab, well, we'll let this particular run finish, which it has done now. If you go to the parameters tab, you can actually visualize this, that there is a user ID and then there is a default 101 value over here, right, of type integer. So even though this flow is parameterized, the quick run doesn't force you to enter a parameter because you have a default value mentioned over there. Now, when you click on run, there is a custom run option over here. If you click on this, then you can override that particular default number. So you can do 1001 over here, and then you can submit this particular custom run. So now this runs as your custom run. So it is gonna have your 1001 user info fetched instead of your 101 user info fetched now over here. All right. So that's about parameterized deployment. Parameterized deployment is nothing but your default flow in your deployment having the ability to accept a parameter. As simple as that, right? So in our user account balance over here, we have the ability to accept a parameter, and it is a parameterized deployment. That's how, right? Okay, so let's run this particular deployment, user account balance deployment over here, and we will go ahead and run it. And either quick run or custom run will force us to enter the user ID because it does not have the reference of any default value over here. So just want to make this point very clear before we proceed that both the deployments that we saw have parameters in them. It just happens that there is no default value in this particular deployment. All right. So while this is running, let's take a quick look. It is done now. And it has taken 1001 as the user ID, more logging in this example, of course, so that's why we are seeing this. Now, all cool, we can trigger a deployment over here by clicking the run button, but we want to use APIs to trigger this deployment and not use this run button over here to trigger this deployment. How do we do that? Let's do that next. So in our, let me close all these other things and let's go to this trigger deployment by ID. So in this use case, you will see that all we are doing is we are using Python's requests library to do a simple HTTP request over here. We'll be building our payload. In our payload, we'll be using the user ID as an example of 101, and we'll be sending this to a deployment ID, right? So what do we need for this use case? We need the deployment ID for this use case. How do you get the deployment ID? You get the deployment ID while you were deploying this, right? So when you were deploying this, you had this deployment ID right here. So what you can do is copy this and you can paste it in the deployment ID over here. And this is your deployment ID now. So your URL that you are formulating, this particular URL, well, it doesn't matter. We are not using over here. We can delete this from here. But this is the URL that we have over here, and we are using the deployment ID over here. Well, just a little bit misplaced code, but doesn't matter. All right, so your deployment ID will be injected into your URL, and this is your API endpoint. Localhost 4200 is the API server for your is your Prefect server, right? So 4200 is where we have been taking a look at for everything. So if I go back over here, you will see localhost 4200 is where everything else is. And then create flow run is the endpoint that we have to finally go to. So the way we reach to that endpoint is localhost 4200/API that exposes all the APIs that we have /deployments. And then which deployment we are talking about? This particular deployment, right? So this deployment and then /create flow run is what actually creates this flow run. And because it's a parameterized deployment, it needs a JSON payload, and we'll create a payload over here. So in the payload, we are saying the parameters are user ID of 101, right? So how do you know what's the name of this parameter? If you go back to your code, you can see that there is in the flow, there is a user ID mentioned over here. So this is how you will be creating your parameters. You can also see this, these two attributes, user ID and deployment ID, you can see all that from your Prefect server too. So let's go to the Prefect server and we'll go to deployments. We'll go to this particular deployment over here, and you can see that in the parameters section over here, right, there is your user ID attribute mentioned as the parameter. And again, in the same deployment, right, user account balance deployment, on the right hand side, if you see at the bottom over here is the deployment ID. So you can copy this deployment ID from here, and you can get the parameter details from here, and you can create your request payload now. So let's do that. So in your code, you have your deployment ID mentioned, and you have your payload created by your whatever parameters you want to pass over here. In our case, it's just user ID. And then what we are saying is that, hey, can you create a flow run for this particular deployment ID, right? And then we're going to just send this request, and we'll get the response back, and we'll see if it actually creates the flow run or not. And once we execute this, because a worker is always listening over here, right? The worker associated with the Prefect server is always listening, and it will attempt to run any flow run that has been scheduled, right? So let's do all that over here. It's very easy to just go to our folder, which we are already in, and run this Python file. So Python, in this case, it is 01, trigger deployment by deployment ID, and hit enter over here. And you will see that it scheduled it. You got the response back. We are just printing this whole response.json over here. And you will see that, oh, we were on the top, so we couldn't visualize it. So it is actually running it. You see simulating task failure and all that. And it is actually running this flow right now. And we can also visualize this on the Prefect server. So if we do a reload, deployments, this is the latest deployment that got scheduled, right? So this is where it ended. So let's schedule this deployment again. Let's run this again, so it will schedule it again, and let's do it by 1013 user ID, and we will visualize this. I'm gonna run this over here, refresh this. So you see this got scheduled from the API. We didn't hit run over here, it got scheduled by the API. And if you come over here to the parameters, the user ID was passed as 1013, and you can see that it is actually running the tasks over here. This is pretty awesome because we had the default worker queue assigned to it. It picked up the task, and it is running the task over here too. Awesome. So now this is cool, but if you see, this is kind of painful to go and get the deployment ID from there, right? Now, if there was a way that you can retrieve the deployment ID by the deployment name, that would be awesome. There is actually an API for that. So this, again, there is a 02 get deployment ID by name. I've created this small little script over here that will fetch the deployment ID based on the flow name and deployment name that we have, right? So in our case, the flow name is user account flow and deployment name is user account deployment. How do we know that? You can always take a look at your YAML file. So you have your user account flow, which is your flow name, your entry point over here, and your deployment name is user account balance over here, right? So where is our code again? 02. So you will see user account flow, and just a second. So our deployment name is user account balance. Our flow name is user account flow. In our code over here, we'll have to adjust it. User account flow and deployment name needs to be user account balance. So let's copy this and let's put this over here. This is our deployment name. Oops, didn't copy it right. Let's copy it again. And let's just paste it over here. All right, user account balance. Let's just save this. So your flow name and deployment name should match for what is actually deployed in your server, which is the same representation as your YAML file over here. And then you'll be able to retrieve the ID over here. So let's now do the Python 02. And let's get the deployment ID by name. And now you'll be able to retrieve the deployment ID for this particular deployment name that you have, right? So we are able to fetch this. So now it's easier, to fetch using the flow names and deployment names sometimes. So you do not have to specify the deployment ID all the time, right? So now the third example is just kind of combination of first and the second example, where we'll be using the API. In the API, we'll first fetch the deployment ID by flow name and deployment name. And then once we have the deployment ID, then we will schedule a run using the deployment ID, right? So the same thing that I have done over here, the deployment name, I'll copy it from here and put the right deployment name over here. All right, so we have the flow name of user account flow, deployment name of user account balance, and we will first fetch the deployment ID by flow name and deployment name. We'll get the deployment ID, and then we'll create our payload over here, and then we will create flow run by the deployment ID that we have retrieved, right? So we've seen all this in the past two examples. It's just a combination of both of them in this one single example over here. So let's do that. So now we will run Python 03 and trigger deployment ID by name ID lookup, right? So we found the deployment ID, we scheduled the run, and now you will see that the worker on the right hand side over here will pick it up. It picked it up. It's attempting to run it, fetching the user info and all that, and checking account balance. And then it will run it now, sending notifications and all that, simulating it, and it will run that. All right, so this is all that I will cover in this video. In the next video, I'll go into the LLM large language model based use case that I have over here. This video has already ran through its course. It's become pretty long already, hour and a half in. So let's call this today. And then in the next video, I'll take a use case of large language model, how we can schedule a task for our LLM interaction as a background task, and then have it run and then execute certain activities using an Ollama server. Thank you guys for watching, and I will see you guys in the next video.